We, the students of Vailtech Multitech, are doing a project on flexible Statcom for mitigation of faults. Now my friend is going to explain about the prototype.
This is our project kit, and we are using 3 parts in our kit. One is transmission line part, and then the Statcom part, and then this is the controller part. And in transmission line part, we are using a single phase transformer, and this will convert the 230 1 amp transformer. This will convert the 230 volt into 12 volt, and I need 24 volts, so I leave this 2 wire, and then I get 24 volt from this wire. And this is my transmission line, and here we want to show some resistance and inductance in the line, so we are using some resistance and inductance here. And then this is my load, and this is a 9 watt load, and this is the Statcom part we are using. And here there are 4 switches in the Statcom, single phase Statcom, and 4 switches are IGBT switches, and this is the heatsink. IGBT is ISA04M kind of IGBT, and then this is the transfer capacitor band, and this is 250 joules capacitor, and this is the transformer, and this will 500 milliamp transformer. This is connected as shunt to the transmission line, and this is the controller part we are using. And then this is the main controller, big controller. We are using 16F877A controller, and then this is the driver circuit, and here the driver IC is IRS2110, and the big controller needs 5 volt as the input. So we are getting this. So we are getting 5 volt from here. For this I am using this transformer. Here the 230 volt is coming as input, and then it is converted into 12 volt, and then this is giving as an input to the rectifier, diode bridge rectifier using. Diode bridge rectifier will convert this 12 volt AC into 12 volt AC, W10M diode bridge rectifier, and then 12 volt AC is stored in this capacitor, and then this is the voltage regulator circuit I am using, and then this is the voltage regulator is LT805. This will regulate the voltage 5 volt to the input to the PIC controller, and then this is the crystal oscillator circuit. This will provide the frequency to PIC controller, and then the PIC controller will operate, and it provides the mother pulse to the driver circuit, and the driver IC is IRS2110. It will generate the pulses to the switches. The one driver IC will generate 2 pulses, and then this driver IC also generate 2 pulses, and this for 2 these switches, and this is given to these switches. And then this is the push switch we are using. First we will create a tag by this load. After switching on this switch, the pulses will be generated, and then this will generate the voltage to the transmission line, and then the tag is clear.
Thank you.